All right, so we learned about this equation, C equals Q over M delta T, which is actually a reordering of our other equation, Q equals MC delta T. Okay, so it's just a reorder of that. This one is solving for specific heat. So solving for the specific heat, we're going to have Q divided by mass and change in temperature. If we're solving for Q, Q is equal to MC delta T. And you're going to see that we're going to reorganize this equation a few times. On the back of your note sheet is this chart. This is a bunch of common specific heats for various objects that you would see in an example problem or you would see more commonly in everyday life. So these are specific heats for these objects at their specific state of matter. So for example, water is on here 3 times. We've got liquid water at 4.184. We've got ice, which is solid water, at 2.093. And we've got water vapor, which is gaseous water, at 1.87 or 1.86. You'll notice that the higher numbers are up top, and it's not exactly in a decreasing order, but your smaller numbers are towards the bottom. And you'll notice that most of your metals that are on here, like iron, copper, gold, silicon, lead, they've got very small specific heat values. And that's because it doesn't take a lot of energy to change the temperature of a metal. Versus to change the temperature of liquid water, it takes a lot more energy, almost 4 times the amount that it takes most metals. Okay, so you'll notice the higher the specific heat value, the more energy that thing needs to change its temperature. Okay? All right, measuring amount of heat entering or leaving. This equation should look extremely familiar to you. They just have it in a different order. They have Cm delta T, but we like our MCAT. So MC delta T is what we use. They just wrote it in a different order. So C is your specific heat, M is your mass of your substance, and then delta T is your temperature change, final minus initial. And this should be on your guys' sheet as well. So at this point, I'm going to pull my camera up, and we're going to do these example problems together. Okay. So we have a flask that contains 800 grams of water, and that water is heated and it increases from 21 degrees to 85 degrees Celsius. Wants to know how much heat in kilojoules did the water absorb. So 800 grams of water, that's going to be our mass. It says how much heat in kilojoules, that means we're solving for Q. That's what we're going to solve for, is our Q. And then our temperature change, 85 minus 21 should give us a temperature change of 64 degrees Celsius. We've got Q, we've got M, we've got our delta T. Looking at our equation, which is Q equals MC delta T, what are we missing that we don't have written on this sheet already? C. If you flip your page over, you will find your C in this chart. So we're working with liquid water. So we're going to find liquid water, and the C is 4.184 joules per gram degree Celsius. Do we all see that? 4.184. So our specific heat for water, C, is 4.184 joules per gram degree Celsius. Okay. So the next thing that we're going to do is we're just going to plug and chug. So I'm going to have Q, that's what I'm solving for, is equal to my mass, which is 800 grams, times my specific heat, which is 4.184 joules per gram degree Celsius, times my temperature change, which is 64 degrees Celsius. If you write all of your units in, you'll see how the units cancel out here. So grams is going to cancel out with the grams that's underneath the unit in the specific heat. And degrees Celsius will also cancel out with the degree Celsius there, leaving us with the unit of joules for our heat. Do we see that? Yeah. We type this into our handy dandy calculator, and we will get a value of 214.220.8, and our unit is going to be joules. Now, did the question ask for joules? No, the question's asking kilojoules. Can I get kilojoules from joules?
Yes.
Yes. How do I do that? We're either going to divide by 1,000 or just move our decimal 3 spots to the left. So 1, 2, 3. This is really 214.22 kilojoules as our final answer. How was that? Start, because there's a typo in it. So this one says how much heat in joules. So this one, you're just going to leave your heat in joules. So we're solving for Q, and you're leaving it in joules. Must be added to 5.07 times 10 to the fourth. This is actually grams. Just so you know, 5.07 times 10 to the fourth. Basically, what 10 to the fourth means is you're moving the decimal to the right 4 times. So really, this is equal to 5, 1, 2, 3, 4. So 0.700 grams. Okay, so that's your grams. You've got to calculate your temperature change. So 250 minus 25 will give you your temperature change. And then this one gives you the specific heat of iron in the problem. So this is your C. Okay, so you have your mass. You're going to calculate your temperature change. You have your C, and you're solving for Q. All right, so your equation that you're going to have for this one is still Q equals MC delta T. So we're still working with that. Your mass was that 5.07 times 10 to the fourth grams. Your specific heat for this one is 0.449 joules per gram degree Celsius. And our change in temperature you should have gotten was 225 degrees Celsius. Your grams and degrees Celsius cancel out, leaving you with joules. And the final answer you should have gotten is 512.196, 7.5 joules. Is that what we got? A pretty big number. Was that 5 million? 5,101,967. So very big number. Obviously, we now know joules are they're like a really small unit. So like in comparison, think of like a joule. Think of it like a millimeter compared to a meter, right? So very tiny compared to a meter stick. So joules are really tiny and kilojoules are like more standard sized. That's why in chemistry more often we use kilojoules, just because it's not writing out this many numbers. It's writing out a third of those numbers. We can also use this equation, the Q equals MC delta T, to calculate for other things. So one thing that you're going to see very often is it's going to ask you to calculate for the specific heat of something. So it's going to tell you this much heat came off, this is the temperature change, and this is the mass. We don't know the identity of the substance. Calculate the specific heat and then identify the substance using this table. So I'm going to show you guys an example of that right down here. So we've got an unknown piece of metal, but we know that it has a mass of 348 grams. So there's our mass. And it says when the metal piece absorbs 6.64 kilojoules of heat, its temperature increases from 22.4 to 43.6 degrees Celsius. So we've got 6.64 is our Q, 22.4 to 43.6. That's going to be a temperature change of 21.2 degrees Celsius, and it wants us to determine specific heat. So we're trying to solve for C. And just so we're all aware, our units for C is joules over gram degrees Celsius. So when we're trying to solve for C, we need to make sure that our mass is in grams, our heat is in joules, and our temperature is in degrees Celsius in order to get the right thing. So are all of our units matching this? Mass is good. What about this one? It's in kilojoules. Can I get from kilojoules to joules?
Yes.
Yes. What am I going to do? Am I going to divide or multiply? So when we go from joules to kilojoules, we divide. So now we're doing opposite. We're going kilojoules to joules. So we are going to multiply. We're going to multiply by 1,000 or move the decimal to the right 3 times. So this is actually going to be equal to 6,640 joules. Now all we have to do is plug and chug. So we have our equation, Q equals MC delta T. But we're trying to solve for C. So in order to solve for C, what am I going to do with M and delta T? divide the equation by those. So Q will be equal to, C will be equal to Q over M delta T. Okay. And now we can plug our variables in. So our Q is 6,640 joules. Our mass is 348 grams. And our change in temperature is 21.2 degrees Celsius. See how we get the joules over gram times degrees Celsius down there? So that's where this unit comes from. When we type this into our calculator, we get an answer of roughly 0.9 joules per gram degrees Celsius. So this is our specific heat. The next thing that we're going to do is we're going to look at our specific heat chart, and we're going to see what specific heats are around 0.9. Now this said that this is an unknown metal. So metal is going to be what type of substance? Solid, liquid, or gas? Solid. So we're going to look for around 0.9. We've got a 0.918, we've got a 0.897, and a 0.853. We've got carbon dioxide and gaseous oxygen. So we know neither of those. Aluminum is a metal and it's 0.897. So could we agree that this substance is most likely aluminum? It is. So I'm going to let you guys try the practice problem down below. I'll give you guys 3 minutes to try that one. It gives you the mass, it gives you the Q, and it gives you your delta T. You're going to solve for the specific heat and identify the substance. All right, so we've got our mass. We've got our Q, and we need to update our Q to be in joules, so that's going to be 1,430 joules. Our change in temp is going to be, what did I write down? 14.6. And now we can plug in. So C is equal to Q, 1430 joules, over mass, 217 grams, times our change in temp, which is 14.6 degrees Celsius. Once you write that in, you should get an answer of 0.45 joules per gram degree Celsius. Since this is a metal, the thing that's closest to it was iron. Questions on this? Okay, what I just passed out to you is a worksheet. This worksheet's going to be due Monday. I built this for you guys this week. This QR code, when you scan it, it's going to bring you up to a Google Doc that includes this specific heat chart. Okay, so it's going to give you the specific heat chart if you need to use it at all during the work when you're working on the worksheet. You scan that code, it'll bring it right up on your phone for you. Okay. I have the two equations, but the equation that you're actually going to be using this entire worksheet that you're going to work with is this specific heat equation, because all of them are dealing with a mass. Okay. So this is the equation you're actually going to be using on this worksheet. I gave you an example problem up top just so that you have that here to kind of help you out. Right down here, the equation rearrangement practice. I'm going to help you guys out with the first one, and then you can rearrange from there. So Q on the first one is going to be equal to C times delta T. And then you'll rearrange to solve for delta T. So if you were using this equation, how would you solve for delta T? The other one, the specific heat equation, Q is equal to MC delta T. And then you're going to rearrange for mass and change in temperature. So you'll rearrange those two. I did want to do number one with you guys, though, because in number one, I give you specific heat in calories. And so I just wanted to make sure that you guys understand how to do number one. And it's the only one on here that has it in calories. I should have changed that, but I didn't. So we've got 5 grams of copper. That's going to be our mass. It's heated from 20 to 80. What's going to be my temp change from 20 to 80? 60. Wants to know how much energy in calories was used to heat copper, and it gives you the specific heat of copper in calories per gram degree Celsius. So calories is another unit of energy instead of joules. So this one gives you your specific heat in calories per gram degrees Celsius instead of joules. So we're still solving for Q, so Q equals MC delta T. We're going to have 5 times 0.092 times 60. And when we multiply that out, we get an answer of 27.6. Our unit is going to be calories. This worksheet's going to be due at the start of class Monday. I'm going to give you guys a sticker on it. That's your spot check on Monday. And then we'll go over the key together. I actually did already finish the key. Just remember my rules with the key. We don't take pictures of it. So key is already up front, made for you guys if you want to check your work as you go. And then you just have a few other things I wanted to point out to you in Google Classroom for today. So I posted an exit slip. The exit slip's going to be due by midnight tonight. So you have until midnight tonight to get your exit slip done. And along with your exit slip earlier this morning, I posted your feedback journal for this new unit. This one, I went with a color scheme of fire because thermochemistry. I've got my girl dabbing up on here. So this one, we're only going to have 5 exit slips in total for this whole unit. So it's a very quick unit. So Energy Basics exit slip has been assigned to you, so you'll fill this in. As a reminder, if you get a 3 out of 3, you still need to make sure you're screenshotting the questions and the correct answer, okay? But the notes can be left blank, and if you get anything besides a 3 out of 3, you're filling out all of the boxes. All right, so what you have to work on today, or what you have due today, I should say. By the end of the hour, you need to make sure you turn in your Exploring Energy Lab. This worksheet will be due Monday, and the exit slips due at midnight tonight, okay?